Hello everyone. In the last video, I had explained about the use case diagram for CSV Uploader. So please follow the old video and go through how to create a use case diagram from the problem statement. I have shared the link to this video in the description of this video's description. Now, in this video, I will try to cover how to identify the classes based on the use case diagram and problem statement. So this, whatever you are seeing, is the use case diagram, right? So let me go through it briefly. So user can upload a CSV, right? So this is the main CSV, and you have others use cases which is being used by the main upload CSV use case. Okay, so there are different relationship between these use cases, right? So we have covered the include and extend. Okay, there was I had intentionally made some mistake here, so I have corrected it here. When it is extend relationship, the display of uploaded symbol. So the sequence is, the user will upload the CSV, and after that validate CSV will fire. It will get executed. Then after CSV file is validated and there are no issues, then we will move on to save the data into database, right? So after that, if there are no errors in the CSV file, then a confirmation message will be given to user in this display of uploaded data in the table use case. Okay, so in case if there are any errors in these steps, we are going to display the show invalid CSV error. So what are these in relationship I have explained in the previous video? Please go through it. So now let's move on to identifying classes based on the use case diagram. Okay, so the classes and the behavior. Okay, so the behavior, the classes are basically the nouns. Okay, in the problem statement or in the use case diagram, you can identify all the nouns like CSV file, CSV file uploader, database, employee, right? So these are the nouns, okay, and behavior, or you can also call it as responsibilities of a class, okay. So the responsibilities are basically your verbs or actions, right? So let's go to that use case diagram. Okay, so in this use case diagram, so you have upload CSV. CSV is a CSV comma separated file is a noun, right? So it's a noun. Then you have database is a noun. Then you have employee data, that is employee is also a noun, right? So I have identified all the nouns and put it here. So these become basically the classes, okay, all the nouns in the problem statement or in the use case. Okay, so then all the actions are the verbs. Verb is what? Verb is basically the doing some work, right? So upload a CSV file is doing work. Okay, user is actually uploading a file, CSV file. So that's a work done by user. So that becomes an action, right? So this is the responsibility of that particular class, right? So whichever the class, we'll identify the classes. Okay, then within a validated CSV, we will have sub actions, right? So to validate, we will have to read the file, isn't it? So otherwise we'll not know what is there in the file, right? So we'll have to read the file and then validate the structure. Say for example the columns, right? So that's the columns, basically the number of columns. What we can set some rules there and validate the structure, and to validate the information whether the data that has been provided is a valid one. There could be some fields which are empty, but they are required, right? So those kind of validations are done. right? So that's actual work, right? It's our action that happens, right? And save a CSV file, that is also an action, right? So this is how you identify a nouns, classes, right, and the actions performed by those classes. Okay, so next, let's move on. So see, the main class here, if you see the CSV file uploader, right? So the CSV file uploader, if you see this box, right, the actual system, the use case diagram becomes the main class. So that is where all your activity is happening, right? Do you agree? So this is a application class, or it's a main class, or it could be a class which will, it could be a controller class in your Spring Boot. So we'll decide that later. It's not now we are going to decide it. It is a parent class where all these actions, all your other classes will sit. So it acts like a container, right? So this is the first step of identifying the classes, right? So let's identify that. So you will have one class which represents your actual system, right? So we will divide them, we will break them up, and we'll decompose. So those things we will see in the next slides. Okay, so then you have other classes: CSV file, employee, database, table. See, I have not mentioned table. So that table also becomes a kind of a user interface, right? So you have a user interface. So still I have not come to the user interface, so I have not discussed about those things. I'm just looking at the backend classes right now. Okay. Okay, this is the first step. So what I've said, we are going to have one main class called as CSV Uploader. Okay. So for now, this is the only class we know. Okay. We will decompose. I will tell you why we should decompose it all. So a CSV Uploader is a main class. So in that class, you have the CSV file and the database, right? CSV file is the input file, and database is where you are going to store. So these are the classes which represent the input and output, right? CSV Uploader is your basic application class, right? It's a main container class which contains other classes. Then you have various actions that is being performed in that application class, like upload a file, CSV file, okay, and read the CSV file, and validate the CSV file, right? Save the CSV file. So these are the different actions you're going to perform, right? See, you have this plus sign and minus sign, right? So the plus sign is basically your public functions. Minus sign is your private function. So you don't need to worry about those things right now. So you can look at any YouTube video on how to write class diagrams and all. The main essence of this video is to identify classes and their responsibilities. See, responsibilities basically is your methods, right? So this is the main class. So there is one big advantage and disadvantage as well. So the advantage is that everything is contained within a single class, right? So whatever you make changes will be done in this class. But there are disadvantages as well. Mostly the disadvantages. Okay, see, don't you think this class is a bloated class? I mean, it has all the stuff, right? See, for example, upload, read, validate, save, everything in one class. What is the problem in having that? See, the problem is whenever you make a change to some portion, okay, say for example, the read or a validate, your validation rules certainly change, right? So you make a change to validate. So whenever there is a change in any portion of the code, your CSV uploader function always gets changed. I mean, it impacts almost any change impacts this class, right? That's not a good design. Okay, so you are giving multiple responsibilities to a single class. So remember, there are solid principles. Okay, so solid S for single responsibility principle. So what does it say? I mean, it says single responsibility. There should be only one reason for a class to change. There should be only one reason. Here you have so many reasons, right? Whenever the uploads, your logic for read changes, you have to upload it, you have to make this change to CSV uploader class. Whenever the validate file changes, you will have to come back and make this change. So you have given a lot of responsibilities to this particular class. I'll give you an example. Okay, let's suppose uh, okay, let's take a hypothetical scenario where you have a team. Okay, you have team only of only one member. He does everything, front end, back end, writing SQL queries, everything. Okay, and he delivers it. He delivers a project on his own, doing everything. Now let's suppose there are some changes, okay, in front end or back end or whatever. What you're going to do? You're going to go to that particular candidate itself, that the one team member. He has to do that change. So it has a lot of impact on him, right? So if everything is done by that single person, your time of implementation, any changes, right? I mean, that person only has to do, and you are putting a lot of pressure on him, right? So any changes he has to go on through. Similarly, you cannot have a class which is a bloated class. I mean, I call it as a bloated class because you have a lot of functionalities assigned to that particular class, right? So any change you want to make, you have to make this change. Okay, so you have to, it becomes a monolith. It is called as a monolith, right? So now, in order to overcome this, there is a single responsibility principle. Okay, so what is done? See, you assign each of this functionality responsibility to a separate class. Okay, so that is the next step. Let's see what is done in the next step. For now, this is not a good design. We have everything in a single class. Let's move on to the next class. Okay, so here what I've done, I have decomposed the monolith class, a big huge class, into three different functionalities, three different classes based on the responsibility. Okay, so what I've done, I have delegated the responsibilities of CSV Uploader to separate classes. First thing is, I delegate the responsibility of reading a CSV file to a CSV Reader class. So the CSV Reader class will have only one functionality, that is only reading. It will not do anything at all. It will read the CSV file and it will return you the list of lines in that file. See, what is a CSV file? Basically, a CSV file is a text file, right? So this class will read each of the lines. So first line is a header line and all other lines are the data lines, right? So it will create a list of classes, a list of lines. Maybe it is a list of strings and return after reading it. So it will do only that job. It will not do anything else. Next, validation. That again I have delegated the responsibility from CSV Uploader to the CSV Validator class. So this class, it does only validation. So what you do, you pass a CSV file, or you can also pass the, okay, it is not CSV file actually, you pass the list of lines. Okay, I have mentioned it here as a CSV file, so you can change it to a list of strings. So it will not do reading, it will do only the validation. It will do only the validation of what, of the data and the header structure, whatever, right? So the list of strings, you are going to pass it to the CSV validator, right? So then next responsibility, saving the data to the database file, sorry, the database. So there also what we'll do, after the validation is done, we can send that data if there are no errors, we send it to what, a database. So database, all the activities, all the responsibilities of a database is given to the database class. So you can imagine, right? Some of them know already the concept of repositories, right? So that becomes your repository class, which will have all your functions like find by ID, save all, save. So that responsibility is given to the separate class. So now what we have done, we have made this highly bloated class into three. So based on the responsibility, we have decomposed into 3 more classes. Now let's go and see. If there is any change in reading, only the CSV reader class will get affected. Then second one, if there is any change in validation, CSV validator will get affected, right? And in database, any changes are there, any table change, anything, only the database class should get affected, right? So like that, your impact. So your CSV uploader class will not get impacted directly, right? I mean, you need not. I will go down further how to improve the effect of the changes made to the internal level code. Okay, so now how is CSV loader uploader going to use these 3 classes? So it is going to create the instances of those classes. What will CSV uploader do? It will create the instances of each of these classes and call the respective functions. Okay, so in read file, what it will do? It will create in read file this particular function. It will call our CSV read file, CSV readers function to read, right? But if there is any change, it is going to impact CSV reader, not the CSV uploader. CSV uploader is just using it, right? Next, validate file. Validate file is going to create an object of validator, and it is going to call that function, right? So that way you have moved all your responsibilities to your 3 different classes. Now let's go back to the example which I gave, right? You have only one team member who does everything. So company had decided that, I mean, they will hire more resources under him, that one single guy. So what will the project manager come and do? He will come and talk to that single person, and he will say, okay, you do this, and this fellow, the person will delegate all the different tasks to 3 different members, right? So it becomes more productive. The same way, the software also becomes highly maintainable when compared to the CSV uploader class, which is very bloated. It's a monolith. Now you are breaking them into small classes. Remember, I'm not talking about microservices here. I'm talking about only the single class, right? The single monolith class is broken down into 3 different classes. We will decompose it further based on various criteria. We will talk about that later. Now, this is how the design is done. See, you are still in high level design. You are still identifying the small classes. You are still in high level design. You are not going to a low level design is where you are actually going to talk about individual functions, how you are going to implement individual functions. So we are still in the high level design. So now let's come back to this step where we have actually decomposed a monolith class to a 3 different classes, right? And this monolith class will depend on these 3 classes to achieve its upload functionality, right? So whenever you call upload, it will use the functionalities provided by these 3 different classes, CSV reader, CSV validator, and database, and achieve the functionality of uploading the file to a database. Now, so what is happening? See, this CSV uploader class is depending on the concrete implementations of the classes. Concrete implementation, that means it is going to create the objects using a new operator, right? So that's also not a good design principles, right? So we will have to use interface segregation. Your solid, SOLID, the I portion, right? Solid interface segregation. So that we need to use. Okay. So what we are going to do? We are going to move to the next step where we are going to do that. So next step is, let's identify the interfaces required. So why do we need interfaces? See, what is happening, CSV uploader is depending on the concrete implementations of these three classes: CSV reader, CSV validator, and database, right? So any changes, right? So that will get reflected even in the a bloated class, highly bloated class. So you are directly depending on that. You are not making it loosely coupled, right? So we need, in order to make it loosely coupled, we should use interfaces. So there is a design principle: always code to the interfaces. Don't write your code for concrete implementations. Okay, so this is a rule. You just need, see, this principles, right? You are going to understand slowly by using them, right? So whenever you have such classes, right, whenever a class is depending on other classes, define interfaces. Say for example, most of you guys know about service implementations and service class, right? So service is always an interface, and service implementation is the one which actually implements the service, and then you use that service interface in your controller class. That is one, I mean, that's hypothetical. I mean, that most of you follow those principles in your Spring Boot applications, right? So what I have done, I have created an interface for each of these three concrete implementations. Three, see, ISV CSV reader, ICSV validator, iDatabase. Okay, so these interfaces will have the function declarations. It will not have definitions, right? So what will happen? All these three classes will implement these three interfaces. Okay, so the CSV reader will implement iCSV reader interface, and CSV validator will implement CSV iCSV validator interface. Okay, and database class will implement high database interface. Okay, so now you have made an interfaces. Now let's go back to the main class, the CSV uploader class. Here, instead of using the concrete implementations of CSV reader, CSV validator, and database, you use the interfaces, right? So you create objects with interfaces. So you can use your AutoWire and Spring Boot to inject those things, dependencies, right? So we'll come to that later when we design actually the classes, actual low level implementation. But for now, so simple, you create one. So let's go back to this first step. See, I will reiterate the things again. So from the use case, you are going to identify one class which will represent like a container to your application class, right? So where will all other classes will sit, right? And then you will identify various methods. So basically the functionalities of that particular class. Then you, in the next step, you'll use single responsibility principle, design principle, to delegate each of the functionalities to a separate class. So upload read file you are going to delegate, a validate file you are going to delegate, a save you are going to delegate to a separate class. So you have three different classes based on the functionality. Okay, so this kind of decomposition can happen till you find a very low grained, I mean, a class. So output is the class will do what will have only one reason for a change, right? Only one reason for change. Okay, so the file reading will do only file reading. Validation will only do validation. Database will do only database operations. So you will do that in the second step, decomposition. In the third step, identify the interfaces and define the interfaces for each one of these concrete implementation class. Now, after you define these interfaces, okay, move on to the uploader, CSV uploader. Wherever you are using a concrete implementations, right? So try to use an interface. So you're making this monolith module very loosely coupled to the functionalities of this CSV reader. So any changes, right? I mean, so you understand the benefits of interface, right? So benefit of interfaces, it makes the dependencies very loosely coupled. Okay, so this can be further delegated into different services, which I will talk little later, not now. Okay, so this is how the entire decomposition of classes, right from identifying the classes. Okay, so then going through design principles and breaking them down. Okay, and you have this interfaces, right? So this is how you are going to identify classes and their responsibilities in this analysis, high level analysis, high level design phase. Okay, so in the next slides or a next video, I will go through. Uh, I will write the code actually. Okay, I will show you step by step. In the first step, I will try to create one CSV uploader class and see how it goes, what are the impacts. I mean, I will show you literally. I will show you how it will impact whenever there is a change. Okay, and then we will have this second step also implemented as a 3 different classes, and third step also will show you. Okay, so that I will cover it in the next video. It is already 25 minutes video now, so please wait with patience. Okay, have a good time in learning these things. Put down whenever you have any doubts, please put down in the comments section. I will try to cover it in the next video. Thanks guys.